Hello everyone, I am Anusha Obaid, back with another lesson on physical quantities and measurement techniques. In our last lesson, we've learned that physical quantities are the quantities that we measure and that they can be categorized as scalar quantities and vector quantities. In our today's lesson, we are going to learn about what are prefixes and how to convert values into the standard form, and also how to add vector quantities to get a resultant value. So without further ado, let's begin. Prefixes, as you can see here, are added to the units of the physical quantities in order to express units that are either very big or very small. For example, we often say milliliters, kilometers, nanosecond, kilograms, then milligrams, etc. These milli, kilo, nano are what we call prefixes. The table here shows the most commonly used prefixes in the metric system. We have giga, mega, kilo, deci, milli, micro, nano, and centi. And just like for the physical units, we must also ensure that we are using the correct cases when writing the symbols of the prefixes, whether the symbol is in uppercase or in lowercase. Converting to standard form. In order to convert values in the standard form, we move the decimal point either to the left or to the right until there is only one digit to the left or to the right of the decimal point based on the position of the decimal point in the value. Let us see these two examples. We have for the first example 42,000, which we can simply write as 42,000.0, and then we move the decimal point just beside 4, so there is only one digit left to the left side of the decimal point. And so we are skipping 4 places. And we write 42,000 is equal to 4.2 into 10 to the power 4, which gives us our answer. In our second example, we have 0.0053, and we write 0.0053 and move the decimal point to the right side, so there is only one digit left to the right side of the decimal point. And since we are skipping here 3 places, we write 0.0053 is equal to 5.3 into 10 to the power minus 3. And in our first example, since we are moving the decimal point to the left side, we are multiplying it with 10 to the power 4, which is the number of places we are skipping. And in our second example, since the decimal point is moving to the right side, we are multiplying it with 10 to the power minus 3, which is the number of places we are skipping. And it is the same as basically dividing it with 1000. And since we are writing it in standard form, we do not write the division sign. Instead, we are just multiplying it 5.3 into 10 to the power minus 3. So when the decimal moves to the left, the exponent goes up, and when the decimal moves to the right, the exponent goes down. Addition of vectors. Now, in our previous lesson, we've learned that vector quantities are the quantities that have both the magnitude and the direction. And we can add vectors to get a resultant value. For this, I am going to use force as our physical quantity to show you guys how we can add vectors. And we will use two methods for that. Method 1 includes simple algebraic addition when the vectors are parallel, and parallelogram addition when the vectors are not parallel. Now let us see how we can do this. Simple algebraic subtraction when the vectors are parallel. Now this method includes subtracting the forces that are acting opposite to each other on an object. Example 1 shows 2 Newton working on the right side and 2 Newton working on the left side. Subtracting this will give us a resultant force of 0 Newton. Then again we have 2 Newton working on the left side and 4 Newton working on the right side. Subtracting this will give us a resultant force of 2 Newton that is acting on the right side, since that is where the greater force is acting. And then again we have 3 Newton working on the left side and 3 Newton working on the right side. Subtracting this will again give us a force of 0 Newton, that is the resultant force. And then again we have 6 Newton working on the right side and 3 Newton working on the left side. Subtracting this will give us a resultant force of 3 Newton that is working on the right side. Simple algebraic addition when the vectors are parallel. Now this method is all about adding the forces that are acting in the same direction on an object. Example 1 shows two forces of 2 Newton working to the left side, and we add them up, which will give us a resultant force of 4 Newton that is acting on the left side. Then again in our second example we have two forces of 2 Newton and 4 Newton working on the right side, We add them up, which will give us a resultant force of 6 Newton that is working on the right side. Again, we have two forces of 3 Newton, and the resultant force is 6 Newton that is working on the right side. And then again, we have 6 Newton and 3 Newton. We add them up, which will give us a resultant force of 9 Newton that is working on the right side. Parallelogram addition when the vectors are not parallel. This method is all about how to find the resultant force when the forces that are acting on the object are neither in the same direction nor in the opposite direction. So what we can do is we can draw the initial diagram on a graph by using the scale 1 centimeter representing 1 Newton, and then make a parallelogram by joining the lines A, D, C and B. And the diagonal that is formed will give us the resultant force, and which we can find by using the y-axis of the graph. And then we can find the exact direction to where it is working by measuring the angles using a protractor. So we can see that the angle ADC is 45 degrees and angle BDC is 20 degrees. So we can say that the resultant force is equal to 8 Newton working 20 degrees from the 5 Newton. That is all for today. Thank you for watching today's video. I hope you all liked it, and stay tuned for the upcoming videos. See you in the next videos. Bye!